Here is the famous airplane or boat with wind or current problem. Okay. Let's see, here's city A and city B. And an airplane can fly from city A to city B. And say you take this trip and it's 450 miles and you get there in 3 hours. Okay, so I like to know the plane's speed, okay? But wait, there's a little catch here. On the way back, they flew back, same exact trip, right? 450 miles, but it took them, they did 450 miles in 5 hours. Why did it take them so much longer? Well, when the plane flies, there's also wind. Okay, there tends to be wind, and wind actually goes across the United States from the west to the east. And if you ever flew from the west to the east, you can actually get there faster than coming back because the wind is blowing. So there's wind that's blowing like this. If you ever rode a bicycle with the wind to your back, you go a little faster. But if you rode into the wind or try to use a skateboard into the wind, it slows you down, doesn't it? So it took them longer. So how fast was the plane actually going? And what's the wind speed? How fast is the wind that caused it to get this way 2 hours faster than that? Okay, so this question, let's start with our basic rule. Distance is rate times time. You know that whatever your speed is, and you multiply it by the time, you get the distance. Like if you could walk 10 miles an hour and you walk for 2 hours, 10 miles an hour times 2 hours, you'd go 20 miles. Okay, so let's put this in. So distance, we have the distance, 450 miles, okay, equals the speed. Now we don't know the speed, do we? So I'm gonna just leave this blank for a moment before I put a letter in there, times time. Oh, we got the time, 3 hours, right? Okay, 3, you can put hours on if you want, but I'm not gonna write it. So you're probably going, well, it's 150, right? But hang on. Now going back, we did 450 miles, but once again, we don't know the speed, but it took us 5 hours. Now here's the catch about the speed. We need to know the plane's speed. We'll use P for the plane. And we need to know the wind speed. So how fast was like the pilot setting the airplane speed? You know, he has the engine, he's pressing the gas, and of course it's not gasoline, well, whatever he's using, jet fuel, but he's, you know, got the throttle set at a certain speed, and it might say like 100 miles an hour on a speedometer, but he's going a little extra faster because of the wind. So how about we use W for wind? So his speed, going there, he got fast. So let's use, we got the plane speed, right? And here we got the plane speed. But how did he get there faster? Because whatever his speed was, he got a little boost from the wind. So I'm going to put the plane speed plus a little extra boost from the wind is his speed when he was going there. But on the way back, whatever the plane speed was, it got slowed down by the wind. So we'll subtract the wind. For example, if you're a little confused on that, let's say the plane speed was 100 miles per hour. And let's say the wind was 20. So he's trying to fly 100 miles per hour, but the wind's slowing him down to like only 80, isn't it? Is 80 times 5, 450? No, it isn't. But see, going there, when he was going, he tried to go, he set the gas for 100 miles an hour, but he got maybe a boost at 20 miles per hour from the wind. So actually when he's going there, he's actually covering the ground at like 120. See how he got there faster? He set the plane at a speed, got a little wind boost. So he actually moved a little faster. Here he went a little slower. So we got to figure out what really is. I just made these numbers up. Okay, so let's solve this equation. Got 2 equations. They're lined up. Now you can't cancel this. These are trapped inside, aren't they? So 2 choices. A lot of people distribute, which you could distribute. I think in my homework, I distributed 3P, 3W, 5P minus 5W, but I got even a better idea. Let's get rid of the numbers. Why don't we just, instead of distributing, which we could, why don't we just go like this? Divide by 3. That way we can just get rid of it. I'm going to write the problem over here. 450 over that is 150 equals P plus W. And we'll do the same thing here. I could distribute, but like I did in my homework, but I'm going to do this as even better. Divide by 5, divide by 5. 450 over 5, and I should use a calculator. That should be 90 is P minus W. Now check it out. Ta-da! Wait, I haven't finished, have I? Lined up, lined up, lined up, lined up. Ooh, and they're already opposite. I don't even have to multiply. Let's just do this thing right now. 240. P plus P is 2P. W minus, don't cross it out because you need it when you plug it in, is gone. 2 times the plane is 240. So the plane is 120 miles per hour. Ta-da! Oh, wait, what's the wind? So we answered the plane, 120 miles per hour. And let's plug it in. Where do you want to plug it in? Anywhere you want. See why I don't cross it out here. Like, hey, why don't I just go up here and plug it in right there? There's a good spot. You can plug it in here or here or here. 120 plus W, 120 plus 30. 30 is the wind. So the wind is 30 miles per hour. Well, make sure it works here. 120 minus 30. Does it work there? Yeah, that's 90. So see, when he flew there, 120 miles per hour, he got a 30 mile per hour boost. So it's kind of like he went 150, isn't it? 150 times 3 is 450. But going back, he had to fight the wind. And even though he's trying to go 120, he got slowed down by 30. So he actually went 90 coming back. Oh, 90 times 5 is 450. Ta-da! So that's the airplane problem. I've also seen it done with boats trying to go up a river or down a river. You know, when they're trying to go up the river, they got to fight all that river going against them.